This is a very quick demo for the 3-bit adder and subtractor. It's a little bit difficult to see the state of the switches, but I'm gonna just tell you what's gonna happen. So these are the labels for each switch. For example, this is A2, A1, A0, which is the lower 3 switches, and B0, B1, B2 for the next 3 switches just next to the first 3 ones. And here's the -1. It's a carry in from the very beginning. So if I switch it on, it's activating that subtractor mode. Otherwise, it's going to be just a regular adder mode. Okay, and so and here's a Samsung display shows the final results, and LEDs shows the binary result, and the 4th bit or the 5th bit or bit 4 shows the overflow indicator. So the lower 4 LEDs are the binary results. Okay, if we take example, for example, 1, 1, 1, 1, 0, 0. Okay, adding together, so eventually it's basically 1, 1, 1 plus 1, 0, 0, and you're getting 1, 1. So it becomes 0. So there's overflow. So you are expecting the overflow indicator should be on. Okay, and because overflow happens, so we should adopt that carry out here. Eventually it's forming a -4 plus 3. This is -8, sorry, -8 plus 3, which is -5. Okay, so here should show -5, and here should show overflow indicator on, and should show 1, 0, 1, 1. Let's see if that's the case. So I'm going to put all these ones on and give a 1, 0, 0 here. You can see it's exactly -5, and overflow indicator is on, and it shows 1, 0, 1, 1, 1, 0, 1, 1. So this is verified, and I can try the other one. Let's say 0, 1, 1 plus 0, 1, 1. Okay, so 0, 1, 1 plus 0, 1, 1, we're having 0, 1. Eventually it's getting a 1 here, so it's also overflows. So we should adopt here, which is basically no carry out, so it's going to be 0. Okay, so we're expecting overflow indicator to be on. Final result is 0, 1, 1, 0, and eventually the result should be 6, right? Because this is 3 plus 3, it should be 6. And 0, 1, 1 plus 0, 1, 1, and it's 0, 1, 1, 0 with the indicator on. Okay, it's also correct. So what if we switch this on? So it becomes a subtractor. So it becomes 0, 1, 1 minus 0, 1, 1 should be 0. Okay, it shows 0. And if we use 1, 1, 1 minus 1, 0, 0, so now it's showing 1, 1, 1 minus 1, 0, 0. Okay, because this is -4, so it's basically so this becomes this is -1 plus 4. So you're expecting +3. So this is what we are getting here. And let's see, +3 should be 0, 1, 1. Okay, 0, 1, 1 is showing correct results and no overflow. And now let's see if there's overflow happens over here. Okay, so 1, 1, 1 minus, because it's always a always an adder, and even though it's a subtractor, we have to convert it back to its positive number. So the -4 is actually +4. So 4, it has to be this, okay, because the sign has to be 0, so that's a positive number. And not changing the value here, so I have to add a 1 in front of it. So it's going to be 1, 1, 0, 0. Okay, so that is why you are seeing 0, 0, 1, 1, 0, 0, 1, 1 as a +3. And because there's no overflows, this bit is being dropped, and we are duplicating the S2 or whatever, and because there's no more bits to hold it, so we are good for now. So it's eventually the final result is 0, 0, 1, 1, and there's no overflow happening here. This is how you demonstrate the result of this 3-bit adder and subtractor.